আমার অ্যাকাউন্ট
পিছনে না না শেয়ারে এটা আইছে
এই শেয়ার স্ক্রিনটা করো না, দুটো লাইক এসে গেছে হঠাৎ করে।
শেয়ার স্ক্রিন
উইন্ডো
ইন্টার স্ক্রিন
উইন্ডো 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 ইন্টার স্ক্রিন শেয়ার শেয়ার প্রেস করো শেয়ারে।
বেশি করিস না
একটা লোক এসেছে, মা তুমি কি ঢুকছো বারবার? ঢুকেছি
কেন আসলো না কেন
আমি কিছু
Hello, friends. We are going to start the live stream for today. So, if you are hearing my voice, so you can respond in the chat box. We have, I think, 3 minutes left for the scheduled time. We are waiting for people to come and join.
জোরে বলো, জোরে বলো।
Hello.
এসছে, এসছে।
Hello. Hello.
আরে আসছে।
Hello. If you can hear my voice, please mm, in the chat box, please respond. We are going to start the live stream presentation soon. We are waiting for some more time before we start the live stream for today's session. Please wait for a few minutes. So we'll wait for another 1 or 2 minutes, and then we'll start for today's session. Okay, we'll start now, and we'll see that how people join after that. So today's session, I have not given in description for today's session. I have just given a title, which is basically Moore's law and nanometer technology in 2025. So when we talk about Moore's law, I just should give some. Before that, I would like to say that today I have not make any formulation of the normal videos that generally I share. It is basically more like interactive basis. So let's start, and then we'll move to any queries or questions, and then we'll take it up. So we'll start with Moore's law. Gordon Moore, he was a co-founder of Intel. So I'm just giving a brief of Gordon Moore and how the Moore's law came, so that that makes things a little more interesting. So Gordon Moore, in the year 1965, he proposed a law. He was a co-founder of Intel, and he proposed that based on his experience, every 2 year, the number of transistor is going to be double in every 2 year in a chip. And it has been found that after decades, even after 50 years, we found that Moore's law is still valid and still alive. And we see that because as the chip size shrinks more and more, and we find that the chip is basically more into starting from 65 nanometer to 28 nanometer, and then we further reduce it, and the more and more transistors are being shrinked into a particular chip. So we found that this Moore's law is going to be challenging, and it's basically very informative out here that in beyond 7 nanometer, it is 4 nanometer, 3 nanometer, and beyond 3 nanometer is basically difficult to continue with Moore's law. So this is the history of Moore's law, and recently we have found that there is a contradictory statement that in 2022, NVIDIA CEO Jensen Huang, he told that Moore's law is not alive, because based on his experience, he said that NVIDIA is working on the GPU, and based on the GPU speed, they are moving on. Further, they said that he said particularly that Moore's law is dead, and also based on the alternative technology, there is different semiconductor packaging by which you can further accommodate more and more chips in a particular die. So that is called packaging. So in 3D IC packaging, there is a vertical stacking, and then there are other options like photonic integrated circuit. We call it as a PIC, by which you can also do some kind of innovation. So, so in that way, the challenge is there that there is an alternative of Moore's law, and also there is a limitation by which we can say that Moore's law is not alive, because lithography is a process by which we prepare chip, and lithography process, there is a restriction that if you go beyond 3 nanometer, it is almost difficult or almost impossible to further reduce the chip size and accommodate more and more transistor. So I will talk about the lithography and all these things. So don't worry about that. That you are not not aware of the lithography or something like that. We go to all these details, and so this is a context that Moore's law. And contradictory statement I have mentioned because I think Pat Gelsinger from Intel, the previous Intel CEO, he told that no, Moore's law is still alive, and based on the work that Intel has been doing, and Intel is still doing a lot of innovation, they observe that the Moore's law is still alive, and they can further accommodate more and more chips in a more and more transistor in a particular chip. So in that way, Moore's law is something that Intel believes that it is still very much alive. So I am just keep on continuing my talk based on the theme. So we talk about tech revolution. So what is tech revolution? Because I mentioned in the title, it is Moore's law and um, nanometer technology in the year 2025. So we'll talk about the tech revolution. We talk about what has happened in the technology, semiconductor technology. So when we started, I think we started with 28 nanometer. Even beyond that, there is further blunt technology. Those are not blunt technology; those are mature nodes. I would say they are very much tested, and still there is further progress on the technology. And now in 2025, we are talking about 7 nanometer technology. We are talking about 3 nanometer technology, 2 nanometer technology. So all these things are happening a lot, but how is it possible to shrink the number of and accommodate more and more transistor in a particular chip? So that is the core concept of lithography. So I should give some brief idea about lithography. Lithography is one of the stage of semiconductor manufacturing. So semiconductor manufacturing starts with silicon ingot, that is a basically cylindrical shaped silicon, 99.99% purity, and then it is cut into slices, and each slice is basically the raw material for the wafer. So on the wafer there is deposition happens, and then photoresist coating has been done. Photoresist material is something which, you know, when it is exposed to the ultraviolet light, some part of the photoresist part is become soluble, and some part of the photoresist part becomes hard. So, so that is the thing. And so in the photoresist coating, semiconductor, that wafer is basically coated with the semiconductor material, that is the photoresist coating, and then the most important part is the lithography part. So lithography part is basically something like that. A small light, UV light, we call ultraviolet light, is passed through a aperture, and a projection has been put on the wafer surface, and that basically creates a print of chip, and the you know um, blue print of the chip is basically put in the aperture. So when this blueprint has been put on before the aperture, this projection has been put on the wafer surface. So that is very interesting. I would say there is lithography machines. There are huge size of lithography machines which basically does all these things, and also this ultraviolet ray passes through a different mirror, and that basically changes different angles of the ultraviolet light to make it more and more accurate, I would say. So lithography is a process by which you can create the print of the chip on the wafer surface. Next step is basically that etching process. Etching process is basically just clean up the rest of the part which is not hard on the wafer surface, just to clean it up out there. And then there is a ionization process in the semiconductor manufacturing. In the ionization process, semiconductor manufacturing, till now, wafer is not very much conductive. So it is just bombarded with ions, and then it makes to make it, mm, conductive to the electricity. So when there is electric current passed to the circuit, it is because of the ionization process in the semiconductor manufacturing. And last but not the least, that is the chip packaging. Chip packaging is very important when it is cut into pieces on a particular wafer. There are numerous, from dozens of chips to a few hundreds of chips can be found from the particular a single particular wafer, which is I think something like 300 meter size, 300 centimeter size out there in the wafer. So this is all the semiconductor manufacturing process. I know it is not very easy to know different stages, but I just wanted to tell about the lithography stuff out there, to know about what is the basic fundamental of the lithography. Now, this is I have progressed on the tech revolution, but I just want to come back and say that since you are working on the semiconductor side of the thing, so either you become a semiconductor designer who is basically actively working on the HDL, Verilog, VHDL system Verilog to directly code for a particular chip, but you should know that which technology you are working on, not which particular type of chip you are working. I'm sure that you know that it can be automotive chip, it can be processor chip, etc., etc. So I would like to say that be aware of which technology you are working on. Maybe you are working on some latest technology, 7 nanometer technology. Maybe you are working on some technology like 28 nanometer technology, but that is also great. I think in India we are have different mature node like 28 nanometer, but these mature node are of 65 nanometer. These mature nodes are very much of uh, well proven for chip manufacturing. Or you are working on a manufacturing side of the things. I know that there are some people who are actively working on the semiconductor manufacturing. You should know that which part of the chip you are actively working on. I'm telling about because you should know that what is the exact role in the semiconductor industry. Or you are working on the CAD. I think there are many people in India and abroad. Abroad also, they are working on the CAD side of the thing. They are working on the EDA software side of the things, electronic design automation, which is very very vital. In order to design a particular chip. I'm not going in detail about the things. You might be working on the simulation side. You might be working on the synthesis side, or you might be working on the placement routing side. So you are a great designer. You are a great uh, EDA software developer, or you are working on the flow development side. That means you are using those EDA software and you are developing a particular process in the flow side of the things. So these are the different roles of the semiconductor in a expansion, and there can be many other roles also. But be sure that what exactly the point of area that you are contributing in the semiconductor ecosystem. So you should be aware of that, and only then you can get some passion out of there, and you can further move further in your career. Because if you start with a particular career like a designer or a semiconductor manufacturing side, or you are a EDA software developer, or you working on the flow development side of the things in great design houses, so you should get some you know um, idea on the technology side or side of the things, so that you can build upon your expertise, and that is very much a golden opportunity in the industry to build on the semiconductor expertise outside itself. But even if you are working on the learning side of the things, if you are a intern side of the things, or you are just trying to move into the semiconductor industry after being passed out, you have some basics of the electronics. You know that what is semiconductor, what is conductor, what is transistor, and what is the gate. The building block of it comes under one level down in the in the gate level, that is the transistor level. So you know that what is transistor, what is gate, what is AND gate, OR gate, and all these things. Those are very important to get into the semiconductor industry and semiconductor designing side of the things. So you must further work on all those things, and also you need to know that what is the application side of the thing. That is the technology, the nanometer technology, which all top chip design companies are further working on to improve on their solidity into the semiconductor business. You should also know about what is the exact how you are contributing to the semiconductor ecosystem, and how it is being used during the semiconductor manufacturing. Because ultimately it is a manufactured chip that comes out, and that manufactured chip that we use in our everyday use, be it a automobile, be it a car, be it a computer, be it a anything. It can be something, some basic like washing machine or refrigerator also. Everywhere there is semiconductor. Everything nowadays you touch, that is a semiconductor. So, and there is a semiconductor boom throughout the world. So there are a lot of scope, lot of opportunity which are coming up. So I think everybody should be geared up to increase your knowledgeability on the semiconductor system. That's why I have just um created this live stream so that you get some direct um, unformulated and unscripted interaction with you. So please drop some comments that whatever queries you have, drop some comments so that I can try to answer those queries, and we can also further move on to the discussion. Before that, I should further continue on the tech revolution in 2025. I talked about lithography. I talked about lithographic machines. Lithographic machines are very costly. They are cost around $400 million. So think of it. And only few companies who create the lithographic machine, and lithographic machine actually makes a hardcore chip out of a particular design. So ASML is a company in the Netherlands who prepare these ASML these high-end UV and UV lithography chips, lithography machines, I would say, and they are supplying these machines to all the top chip giants. They are supplying the chips to Intel. They are supplying the chips to supplying the machine to TSMC. They are supplying it to Broadcom. I think recently they have supplied five $400 million machines to these three companies. We'll talk about that. This real world companies, how they are dealing with these machines and how they use these and utilize those machines in their actual chip manufacturing and actual chip fabrications. So there will be a lot of interesting stories out there. We'll go further into it. Drop some comments, whatever you think about. If you want to like to discuss more on the chip designing side, chip verification side, and also chip manufacturing side, drop some comments so that we can also take our discussion to that layer, and we can further talk about all these things. But I will further continue on this today's topic. So, what is the real world impact? So, real world impact on the chip nanometer technology in 2025 is that the biggest news of 2025 is that Intel is doing a risk production of 18A technology. Now, what is 18A technology? 18A technology is basically 1.8 nanometer technology. So 1.8 nanometer technology, why Intel is doing? Because they want to make this is not a general upgrade of some technology. It is a new technology. I am giving this example because we should all know that these are the top chip design and chip manufacturing companies: Intel, Broadcom, TSMC, and they have just started with Intel. And the biggest innovation in 2025 that is going to be 18A, and they are doing a disc production, but they are planning it to large scale production in the second half of the 2025. This has two technology. One is basically the ribbon fed technology. This is the extension of the FinFET technology. Ribbon fed is nothing but get all around transistor, so that it optimizes the size of the chip and also gives other optimization in the chip efficiency itself. So this is a gate all-around transistor technology, and Intel name it as ribbon-fed technology. The second technology that is coming with 18A is basically power via technology. Power via is nothing but uh, power is coming on the back side of the chip. So that means on the front side there are a lot of exposed places because the power connection is coming from the back side. So from the routing perspective, I am sure that there are some people who work on the routing side of the things. They basically know that there is a routing space exposed because you do a backside of the um, cheap things. Uh, um, so that is a Intel side of the things. So that is a power via, and also Intel also has some other things like 18AP and 18APT. 18AP is basically the power optimized version of Intel 18A, and PT is basically customized version, and this is basically AI for particularly for AI and particularly for um, high performance computing HPC we say. But they are not for 2025. They have started doing R&D, but they are planning it for 2026 for 18AP and 2028 for 18APT. So those are the things, and I will quickly jump into the TSMC before I further go into the Moore's law and going the things. TSMC is working on the 2 nanometer technology. 3 nanometer is basically they have just the production in 2025. 2 nanometer they have orders. They have orders from all top you know chip designing companies. I think they have recently got order from Broadcom, and some order has been moved from Broadcom and it came to uh, TSMC side of the things, and so this is something they are doing, and Broadcom. When I talk about the Broadcom, they prepared the networking chip in the 2025, and they basically trying to do 3 nanometer 2 nanometer technology, but their yield or success rate is not great. That's why customer like Google, they are basically moving to TSMC for their 2 nanometer technology side of the things. So these are the top technology. I think I should also mention Huawei also doing 7 nanometer technology, and they are using the DUV lithography machine for doing this 7 nanometer technology itself. So that is the thing. And when I talk about Moore's law, I started with the Moore's law, whether it is a alive or whether it is a dead. But since lithography process is something we have on the high NA UV lithography, high NA UV lithography is something which helps to increase the transistor density of a chip by 3.7 times. So that basically proves that more and more transistor is possible to be, you know, uh, put into in a small space within the chip. So this is a particular proof that high-end UV machine that ASML has prepared and now deploying it to the top customers. It is possible that other transistor can be put into the single chip. So that means that Moore's law is valid, I would say, and let me know what is your take on it. If you think that Moore's law is valid, or if you think that Moore's law is not alive, and if you think that in a near future people will switch to the different technology, something like 3D packaging technology, something like stacking on the chip to reduce the space, or you are doing, you know, photonic integrated circuit kind of things. So do let me know in your comments. And also, I would like to see that what is your thought before I close the live stream for today. So let me know what is your thought in the comment section, so that it helps me to further, you know, discuss on top of this topic, and that will be a very much interesting side of the things. And the future technology, I will not talk beyond 2025 in this today's video. Though I have mentioned that Intel is planning for 2026 and 28, every other customers, every other chip design manufacturing companies, they are also planning beyond 2025, 2026, 27. They have some plans for 2 nanometer, even 1 nanometer technology itself. So, but that is far beyond. Now it is more on the 3 nanometer technology or 4 nanometer technology we are talking about. So do let me know what you think about this. And also, I would like to say that subscribe this channel, where this channel I talk about semiconductor. This channel I talk about all kind of artificial intelligence. I have not discussed much about the artificial intelligence in today's video, but regularly I discuss and provide my blogs on the artificial intelligence regularly in my blog channel, and also on the LinkedIn side of the things. If you are following me in the LinkedIn, you must be knowing that there are blogs in the semiconductor and artificial intelligence, and also semiconductor manufacturing, design verifications, and all these things. So subscribe this channel. I would say that you will get latest video updates, and also any kind of comments, any kind of suggestions, let me know, that so that I can make further discussion, further live streaming, and further video, YouTube video on those topics. And last but not the least, I would like to mention that I have recently published a book called Semiconductor for All, and this basically discusses about it. Talks about semiconductor in detail, and it talks about artificial intelligence. It talks about semiconductor manufacturing. It talks about EDA as well, and how EDA can be applied in semiconductor manufacturing and semiconductor design. So these things are also covered in this book. So I would like to say that you just go and try to get a glimpse of the book, and you can also purchase a book from Amazon. You will find this semiconductor for all in the Amazon link for this. And I think that's it for today. I would like to say, wait for next video to come, and wait for the next live stream to come. But I would like to say that let me know what you think about today's live stream through your comments or through your suggestions. And yeah, so that's it from my side. Um, so wait for the next live stream and the next YouTube video to come. And before that, Subhashish Chakraborty signing off for today's live stream.